Space is not just vast. It is hostile to human intuition. For centuries, we believed the universe could be understood through elegant laws and predictable structures. We built theories, refined equations, and convinced ourselves that reality, at its core, made sense. But in the last few decades, astronomy has begun to uncover objects and phenomena that quietly undermine that confidence, not violently, not dramatically, but persistently. Today, telescopes no longer simply confirm our expectations. They reveal anomalies, structures that should not exist, objects that behave in impossible ways, and regions of space that defy our best models. These discoveries do not merely challenge individual theories. They force us to question the very assumptions on which modern cosmology is built. In this journey, we will explore some of the strangest confirmed objects and the most unsettling hypotheses in contemporary astronomy. Not science fiction, not speculation detached from data, but real observations, measured, catalogued, and debated by scientists, each one quietly threatening to rewrite what we believe about the universe and our place within it. This is not a story about answers. It is a story about cracks in our understanding. Most planets are born tethered to stars. They form in warm disks of gas and dust, bound by gravity, locked into predictable orbits. But not all planets stay where they are born. Scattered throughout the galaxy are worlds with no sun, rogue planets, also known as orphan planets. These objects wander alone through interstellar space, frozen, invisible, and almost impossible to detect. The first hints of their existence appeared in the early 2000s, but only recently have astronomers begun to confirm them using gravitational microlensing. Brief. Distortions of light caused when a massive object passes in front of a distant star. Some of these rogue planets are giants, larger than Jupiter. Others may be rocky worlds not unlike Earth. What makes them truly unsettling is not just their number, but their origin. Most are thought to be violently ejected from their parent star systems during gravitational chaos, close stellar encounters, unstable orbits, or planetary collisions. In the Milky Way alone, there may be hundreds of billions of such orphaned worlds, silently orbiting the galactic center, or in rare cases, drifting entirely between galaxies. If a rogue planet were to pass through our solar system, we would likely detect it only at the last moment. Its gravitational influence could destabilize planetary orbits, alter asteroid trajectories, and trigger long-term catastrophic changes. A silent intruder, arriving without warning, leaving destruction without ever being seen. The universe is not empty space. It is filled with wandering threats. In January 2014, a fireball streaked across the sky near Papua New Guinea. At the time, it seemed unremarkable, just another meteor burning up in Earth's atmosphere. But years later, something extraordinary emerged. In 2019, astronomers Avi Lubb and Amir Siraj analyzed classified data from US Space Command sensors, systems designed to track ballistic missiles, not meteors. The object's speed was staggering, approximately 45 kilometers per second. Far faster than typical solar system debris, its trajectory suggested something unprecedented. It may have come from interstellar space. If confirmed, this object, known as IM-1, would be the first known interstellar meteor to strike Earth, predating even Oumuamua and Borisov. But there was a problem. The precise measurements were classified, without full access to the data. Much of the scientific community hesitated to officially recognize its origin. Lubb, however, was unconvinced this was an ordinary rock. The object did not disintegrate high in the atmosphere as expected. That implied exceptional structural strength, possibly stronger than any known natural meteor. Some even speculated, cautiously, about artificial origins. In 2023, Lubb launched an ocean expedition aboard the vessel Silver Star, using a magnetic sled to collect microscopic spherules from the seafloor near the impact zone. Hundreds were recovered. Some contained unusual elemental ratios not typically found in solar system material. Were these fragments of an interstellar object? Or something even stranger? No definitive proof exists, yet, but further expeditions are planned. And if larger fragments are found, humanity may, for the first time, physically hold material that formed around another star. In 2019. Astronomers using the Australian Square Kilometre Array Pathfinder radio telescope stumbled upon something profoundly unsettling, gigantic, perfectly circular structures, radio rings, floating in deep space. These objects do not emit visible light. They cannot be seen with optical telescopes. They reveal themselves only through faint radio emissions, and their size is almost incomprehensible. Some span distances many times larger than the Milky Way itself. First, scientists assumed a simple explanation: shockwaves from galactic collisions, remnants of colossal explosions. But no debris was found, no energetic cause, no evidence of violence, just vast, silent circles appearing to emerge from nothing. The most plausible hypothesis suggests they are formed by ancient galactic winds, streams of energy and matter expelled during intense star-forming periods billions of years ago. Each ring appears centered on a galaxy, as if the galaxy once exhaled with unimaginable force, inflating a cosmic bubble that still lingers today. Yet even this explanation feels incomplete. Why are the rings so symmetrical? Why are they so rare? And why do they appear only in radio frequencies? These structures challenge not just our models of galaxies, but our understanding of how energy moves through the universe on its largest scales. For decades, Mars was considered humanity's best hope for finding life beyond Earth. Red deserts, ancient riverbeds, a familiar planetary surface. But today, the most promising candidate for extraterrestrial life in our solar system is not a planet at all. It is Europa, a frozen moon orbiting Jupiter. At first glance, Europa looks dead. A smooth shell of ice, scarred by long cracks and fractures, floating in the intense radiation of Jupiter's magnetosphere. No atmosphere, no sunlight beneath the ice, temperatures far below anything life on Earth should tolerate. And yet, beneath that ice lies an ocean, not a shallow sea, but a global ocean, tens to possibly over 100 kilometers deep, containing more liquid water than all of Earth's oceans combined. The reason Europa's ocean exists at all defies everyday intuition. Jupiter's immense gravity constantly stretches and compresses the moon as it orbits, generating internal heat through tidal friction. This process, known as tidal heating, keeps the ocean from freezing solid. Despite Europa's distance from the Sun on Earth, life thrives around deep-sea hydrothermal vents, environments with no sunlight, crushing pressure, and chemical energy as the primary fuel. Europa may host similar conditions. In 2024, NASA launched the Europa Clipper mission. Over dozens of flybys, it will scan the moon's surface, search for plumes of water erupting into space, and analyze the chemical composition of the ice. But this is only the beginning. Future mission concepts involve autonomous ice melting probes capable of drilling through kilometers of frozen crust, releasing submersible drones into an alien ocean, the first direct exploration of an extraterrestrial sea if life exists there. It would prove something profound: life does not require Earth. It requires chemistry, energy, and time. Now imagine the opposite of abundance. Imagine regions of space so empty that even emptiness feels exaggerated. These regions are called cosmic voids. They're not small gaps between galaxies. They are colossal volumes of space, hundreds of millions of light years across, containing almost nothing. No clusters, no bright galaxies, barely any matter at all. One of the most extreme examples is the Boötes void, discovered in the early 1980s. Its diameter is roughly 300 million light years. Within that space, astronomers expected to find thousands of galaxies. They found fewer than 60. Even accounting for cosmic expansion, such an enormous absence of matter is statistically unlikely. According to standard cosmological models, voids should exist, but not this large, not this clean, not with such sharply defined boundaries. Some speculative ideas have been proposed. Unusual distributions of dark matter, early universe density fluctuations, exotic inflationary effects, and then there are ideas scientists rarely discuss publicly. What if voids are not regions where matter never formed, but regions where something removed it. The shapes of some voids are disturbingly smooth, almost artificial in appearance, as if sections of space were carved out, leaving behind clean edges instead of gradual transitions. Today, voids are believed to occupy up to 80% of the volume of the observable universe. The universe, it turns out, is not mostly filled with galaxies. It is mostly nothing. When astronomers look deep into space, they are not just looking far away. They are looking back in time to in 2024. One discovery quietly shook the foundations of modern cosmology, a galaxy known as Jade's GSZ 14-0. Its light began its journey toward Earth more than 13.5 billion years ago, when the universe was only about 290 million years old. That moment in cosmic history was supposed to be simple, hot, chaotic, primitive according to our models. The universe at that age barely had time to form the first stars, let alone massive, structured galaxies, and yet, this galaxy exists not as a faint smudge, not as a fragile cloud of gas, but as a bright, surprisingly mature system, possibly containing hundreds of millions of stars. To exist at all, it would have required rapid star formation, early heavy elements, and large-scale organization, all processes that, according to theory, should take far longer. This creates a problem that cannot be ignored either. Our models of galaxy formation are incomplete. The early universe evolved much faster than expected, or the timeline itself is wrong. None of these options are comfortable. What makes this even more unsettling is the nature of observation itself. We are not seeing this galaxy as it is today. We are seeing a frozen moment from the universe's infancy, a moment that should not contain anything this complex. The deeper we peer into the past, the more the universe seems to whisper the same message. We may have misunderstood our own origins. Now take a step back, far beyond individual galaxies, beyond clusters and superclusters. Astronomers have discovered structures so vast that they challenge the very idea of how the universe is supposed to work. The Hercules Corona Borealis Great Wall stretches across nearly 10 billion light-years, roughly 1/10 of the observable universe, according to standard cosmology. Such a structure should not exist. After the Big Bang, matter was supposed to spread out smoothly on large scales. Small clumps could form galaxies. Slightly larger clumps could form clusters. But beyond a certain size, everything should even out. Reality disagrees that if this structure is real, and mounting evidence suggests it is, then something fundamental is missing from our understanding. Gravity may behave differently at extreme scales. Dark matter may be far more influential than we imagine. Or the early universe may have been violently uneven from the very beginning. And here is the quiet, terrifying implication: if the universe can form structures larger than our theories allow, if galaxies can appear earlier than time itself seems to permit, if vast regions of space can exist where almost nothing remains, then the universe is not just bigger than we thought. It is stranger. We often imagine science as a steady march toward clarity, each discovery bringing us closer to a final answer. But cosmology is revealing the opposite. Every new observation expands the mystery. The universe does not feel like a finished story. It feels like a question still being asked, and perhaps that is the most unsettling realization of all. We are not standing at the edge of understanding. We are standing at the edge of what can be known. The universe existed long before us. It will exist long after us, and yet, for a brief moment in cosmic time, it has produced something extraordinary. Observers capable of wondering why it exists at all. Maybe that is our role, not to conquer the cosmos, not to solve it completely, but to witness it, to question it, and to accept that some mysteries may remain forever out of reach. The universe does not owe us answers, and still, we keep looking.